So, lecture 44. And a couple housekeeping things before we answer some questions. So I've made an official decision about the final. It will be uploaded to Canvas next Wednesday. It's due a week from that day on the 13th. And actually, I will accept all assignments up through the 13th. So I don't care if you haven't submitted homework 2 yet. You have up until May 13th to submit these things. Is that clear? Hopefully. Wow, that doesn't look good. What the heck? It's like, I got to figure out a better method to this online teaching stuff. Okay, any questions about that? Another thing I'm going to do is I'm also post some extra credit stuff. Again, I don't know. I'm not saying you have to do it. Don't feel like you need to do it to get an A. I'm just going to give you guys different avenues to give me information that you know. As I've said a few times, I have no idea what kind of environments you guys are dealing with right now. I know my house is crazy, and I have, I got space here, and it's nuts with 2 little kids, and so I don't know, and I don't know. Some of you might be, like I said, I have no idea if you're living with roommates, family, who knows? You stuck in your bedroom. I have no idea what kind of learning environment is, and I don't want to stress you guys out more than I have to, but I do need to give you a test. And so I'm trying to give you a week to do it in case you have questions and in case it's hard for you to find quiet time to do the damn thing. So don't forget that my grading policy has changed. If you submit everything, I don't care how good or bad it is. If you submit everything, you're going to get no lower than a C. That's it. So some of you are probably like, yay. And hell, you never know. I'm lazy like you. You might just submit it. If I see the email that says homework 3, I might not even open it to see what's on it. You could just send me an email. And if I see like a little attachment with that there might be something there, I might just give you points. In all seriousness, now I do hope if you can that you try to learn this stuff, and not just for me because I don't give a damn, but for yourself to try to challenge yourself to learn some hard stuff. Actually, I shouldn't say I don't give a damn. I do give a damn. I'd like you guys to be curious and inquisitive and want to learn cool things. And I think calculus is awesome. It's just the thing that stinks about calculus is it's hard to learn. So anyhow, cool. All right. That being said, I babbled enough. Of course, you guys probably missed that. Does anybody have a question? Abdullah, you said you did. What was your question?
On homework 11, question 4A.
Homework 11, 4A. Okay. Let me pull that up. Give me a second because what is happening here? This is the spring of 2020. This is Calc US 2, homework 11, 4A, you said, correct? Oh yeah, great. So let's talk about these. These are great examples of how useful power series are. So 4A, let's separate this. As the great Biggie Small said, we separate the weak from the obsolete. Okay, so basically we want to start with a geometric series. So we start with this guy. Now we know, well, you should know, that this relationship is true, provided, of course, that x lives between -1 and 1. So what's amazing is that from just knowing the geometric series, we can generate countless more power series. So in 4a, I want you to determine a certain power series. So the first thing you're going to want to do is you're going to say, okay, the power series you're after is 1 minus 3x downstairs, not 1 minus x. So one of the things you ask yourself when you're trying to determine power series is, how can you get there? Do you get there by differentiating like we've seen? Do you get there by integrating? Do you get there by just a standard substitution? And in this particular problem, the way to get there is through a basic substitution. And so if you set, I'm going to replace x with 3y. So if I replace x with 3y, I get 1 minus 3y. And then I'm going to replace x with 3y on the other side. I get 1 plus 3y plus 9y squared plus 27y cubed. Now, when is this true? Well, this is true provided -1 is less than 3y is less than 1. Does this make sense? So again, feel free to stop me if you're curious or you have a question about what I'm doing. Now, I didn't have to use y, but I think sometimes it's easier to learn my thought process if I switch variables. I could have kept x in there. And we'll eventually revert back to x at the end. Does anybody have a question about this? Now, a good piece of advice I would give you is every time you do these things, go to the Desmos and make sure that the graph is agreeing with what you wrote down. You know, graph the function on the left, and then graph like the first few terms of what's on the right and make sure the graphs match. Because if they don't match, then you're doing something wrong. Okay, so that's my first step. Now, this means I have the denominator matching to what I want. And by the way, how do we know this is legal? Well, we know this is legal because there's that big theorem I said, the magic theorem that says you can treat power series like polynomials. So one of the things we can do is we can compose them. And that's what I just did. I just composed them. I replaced x with 3y. Okay, so in order to finish this one, all I have to do is now multiply both sides by 2x cubed. So if I multiply both sides by 2x cubed, I have this. Now, what was on the previous slide? Well, the first guy was 1, so this just becomes 2x cubed. Okay, now what was the next guy? Well, the next guy was 3y or 3x, whatever letter you want to use. So if I use, if I do that, hey, Rick, what's happening? Oh, okay, you're fine. You want to come learn?
Oh, can I come in, Ryan?
Yeah, Rick. Rick, you get all these people. They want to see you. This is Rick. Rick, say hi. This is Big Rick. This is the father-in-law. He loves thumbs up. Yeah. What are you dropping off?
Woo!
This ain't social distancing, by the way, so don't snitch on us.
On
the CDC right now.
Yeah.
See that?
CDC. What's up? What are you dropping off?
That box, it was Amy's car.
Oh, okay, cool.
Yeah.
Oh, so you give it to me now.
Well, it's, you know what? It's stuff out of her. Yeah, but she wanted to drop it off in my garage.
Yeah, I know.
Do you see my garage?
I do, yeah.
I can't.
Now
I
we'll
gotta
take up
come
space
out
there.
and turn around.
We should just burn it.
No, there's stuff in there that's, you know.
Alright.
I took the bicycle or Och's Hot Wheel,
Yeah.
or Och's, Lydia's Hot Wheel, and Ricky's trike
Yeah.
up there.
Oh, you took them up.
I took them up. She's going to put them in the car.
Okay.
Coming back.
All right.
Hopefully, it'll
Oh,
fit.
I see what you're saying. Okay.
So they're having a blast.
That's good. All right. Well, thanks, Rick. I appreciate
All
it.
right. Nice meeting everybody.
Yeah. Daryl said
Rick.
we're sleeping. Let's see how many are on here. There's 14. Cal 2 with the biggest turnout always.
Wow.
My favorite, 14. Yeah. Very good. They're all. I should just give them all A's
What
because
do you usually have in a classroom?
I don't know how many. Probably 25 in this class.
wow.
Yeah. I'm not sure. I'd have to do the numbers. By the way, I'm going to erase this because I don't want to jump too far and lose you guys. Because let me write down what I had on the previous page just so we don't lose you all to the joys of it. All right, Rick. Thanks, dude. I'll see you later.
Take care.
All right, you too. So we had this. We had 1 minus 3y. And then if you remember, it was 1 plus 3y plus 9y squared plus 27y cubed. And by the way, this is true on negative 1/3 to 1/3. So all I did was rewrite the last line from the previous page, just so we don't lose you guys. And so now, it doesn't matter what letter I use, but now I'm going to multiply both sides by 3y squared, or no, 2y squared, 2y cubed, excuse me. See, Rick comes here and gets me all confused. Oh my God, I did it again. Can you guys fire me already? I might need to get fired because I don't know if I can do another semester of teaching online. This is just not fun. So now I'm just going to multiply both sides. So on the left-hand side, it's just that. Now on the right-hand side, I just distribute it to every term. So it's 2y cubed plus 6y to the 4th plus 18y to the 5th plus what to the 6th, 2, so what, 54y to the 6th, and that goes on forever and ever. And we know that this converges between for y between negative 1/3 and 1/3. And that's it. You're done. Now, if you want to get brave, and this isn't easy, that's why I say if you want to get brave, try writing that right-hand side in summation notation. It's actually not hard to do. You're all capable of doing it. You should try it. But that is a perfectly valid expression right there. Does anybody have a question, comment?
Why does multiplying 2y cubed does not affect the interval?
That's a good question. It doesn't. Look, there's a couple ways I can answer this. It could, but it doesn't, provided. Look, we had a theorem, so it doesn't because the series already converges. So a short answer for this is the series that we gave you, the geometric series, it's already convergent. And since it is convergent, the theorem tells us that we can multiply a convergent series by any power of x, and it doesn't change the interval of convergence. Now, if you want to see a detailed logical reason, you'd have to take a higher level course where you prove that theorem. But again, our generic reasoning here is any series that converges on its radius of convergence, you can multiply it by a power of the variable, and it doesn't affect the radius of convergence. So it doesn't affect it. The only time it affects it is when I am composing it. Does that make sense? So the theorem states that when you compose it, and I composed it first, so I did two things here if you think about it. I took my geometric series, I first composed it with 3y or 3x, whatever letter you want to use, and then I multiplied it by something. So that's not going to change the radius of the interval of convergence or radius of convergence. I don't know if that's an answer that you feel sufficient about, but if you want, what you can do to convince yourself, another thing you can do is go get go use the ratio test and look at the ratio of convergence on the other side. Does it change? So you can attack that question from two angles if you want. You know, and what I'm saying is go apply the ratio test to that new series you obtained and see where it converges by the ratio test. Now, in order to do that, you'd have to see what the general term is, and that's not terribly difficult to see how to obtain that. But, you know, that's one way you can get to the bottom of it. Does that answer your question?
Yeah.
Now, don't forget, the endpoints are fair game too. You'd have to check those independently. Maybe it converges at 1/3, maybe it doesn't. Now, look at this example. If you replace y with 1/3, well, then the damn thing doesn't even make sense on the left-hand side. See what I'm saying? The left-hand side is undefined at 1/3, but it's not undefined at -1/3. So you got to be very careful with how you study these things. And a good way to get a feel for that, Abdullah, is to just go graph it on Desmos and see what you think. What does your intuition, what does the technology suggest? And then if you want, you can go actually use the ratio test to determine the interval of convergence. Does that make sense?
Yep.
All right. What about the other two? So to get B, does anybody have a question about B or C? B is a little, B you just differentiate a couple times. C is a little more intricate. You have to compose and then integrate and then multiply. So C is a little trickier. Does anybody have any questions about those? Comments, concerns?
Can we go over a problem like C?
Yeah, we can do C. Why the heck not? Let's do C. So again, these are kind of like these are kind of like puzzles. These things, and the more you do, the more you realize how you can pick them apart to get what you want. I mean, I could have easily just said, give me a power series for C without even telling you to start with the geometric series. So that being said, here I give you this initial hint because you guys are just, you know, you're still babies and you're not exactly sure how this works. So we're trying to give you some, you know, sort of like give you training wheels. So here's what I would start with. If I'm looking at C, the way I like to think of it is I like to think of it like, well, here, let's do it slightly different. Let's get a power series. How about, I don't know, how about 1/3 x to the 4th log of 1 minus 8x. So we'll change the numbers around a little bit. Hopefully you can put the pieces together. So here's what I'm thinking. And I'm not going to use different letters this time. I did it in the first example. Hopefully you'll see that that's not necessary all the time. It's just a good way to learn. So I'm going to start with my basic geometric series. And again, it's always nice to remind yourself of when it makes sense and when it doesn't. So I'm reminding you now, the learner, that this, or the viewer, the reader, whoever, that this series converges between -1 and 1. So the next thing I'm going to do is I want a minus 8x. I don't want an x. So I'm going to replace x with 8x. And when I do that, I get 1 plus 8x plus, maybe I'll help you see it like this. Now, how does this change the interval of convergence? So how this changes is it's the interval. The big theorem says that whatever you substitute for x would just substitute it in here. So now we know that this one we just wrote is good between -1/8 and 1/8. So I don't know if that's clear. So that's the first step. Now, the thing is, how do I get a log? Well, here's my thought process. I know that the guy on the left-hand side, if I integrate it, I know 1 over something being integrated becomes a log. I know that. Now, you might not know it the same way I do, so that makes this much more difficult for you. But my experience tells me that I can now integrate these things. So this becomes, 64x squared. I'm not going to write all these terms because it's unnecessary. And so when I integrate the left-hand side, some of you can do this rapidly. Others will have to write out. It requires a u substitution. And what you end up getting is you get -1/8 the log of the absolute value of 1 minus 8x. Now, if you don't even see how I got that, then do the u sub or just check in your head by differentiating. Okay, so that's what I have on the left-hand side. Now, on the right-hand side, what do I get? Well, this is a quote-unquote polynomial. Really, it's a polynomial of infinite degree. It's a power series. And the big fancy theorem says I can integrate it. So I get x plus 4x squared plus, well, what's 64 over 3? Well, 64 over 3 can't be simplified, so I'll leave it as 64 over 3, x cubed. And then the pattern continues. So a lot of you might say, you might be thinking, well, why did you only write the first 3? Or how many do you want us to write? Well, you can kind of see how many I choose. I'm kind of going until I run out of space. Like, I'm not going to squeeze 8 terms in there, because once you see the first 2 or 3, you can see the pattern. Now, I should be careful when I say that. I'm not suggesting that you see the obvious pattern that I do, because you don't have as much experience as I do. But if you write down the first 2, 3, or 4 of them, then anybody can work out the pattern. So unless I specifically tell you how many terms to show, just use your judgment. Does that make sense? All right, so again, where is this converging? Well, we know it's converging for these values of x. Okay, now the problem states, though, I don't want this particular power series. I want to multiply it by the power of 4, or x to the 4th, and then I need to divide by 3. So I have to do some algebra now. So the last thing to do is to get rid of that 8. I'm going to multiply everything by 8, both sides by 8. And to get rid of the minus sign, I'm going to multiply both sides by the minus sign. So if I multiply the left-hand side by -8, I'm just log of 1 minus 8x in absolute value. And on the right-hand side, if I multiply everything by -8, I'm left with -8x. And then what's the next term? The next term is -32x squared. And then if I multiply the third term by 8, whatever 64 times 8 is, I don't even know. What the hell is 64 times 8? 64 times 8. 512. So and so that pattern continues forever and ever and ever. And then the last thing I'll do is multiply everything by, what did I want, a third? X to the fourth? So -8 thirds, x to the fifth, minus 32 thirds, x to the sixth, minus 512 thirds, x to the seventh. And so that answer is sufficient because that's all I asked you for. I just asked you to give me, oh, excuse me, I shouldn't say that. I mean, again, to finish this problem, you need to check the endpoints. You need to check what happens at -8 and what happens at 1/8. Does anybody have a question about this?
Should it be 512/3 on the top?
On the top?
Because you have 64/3. Then when you
Yeah. You're right. I'm sorry. I forgot the 3. So yeah, so then down here, you're right. So this is over 3, and then this would be over 9. Thank you for correcting that. That is a good point. Correct. Correct. Any other questions about this? Does that make sense? Anybody? Comment, question?
So this is as far as you would want us to go.
Wait, if it was what?
So this is as far as you want to.
Oh yeah, that's well. I'm not technically. I mean, you have to check. I mean, the last thing you have to do is it remains. Yeah. So here's what you have to do. It remains to check the endpoints. So what you need to do is you need to plug x equals -1/8 in and plug x equals 1/8 in and see what happens, just to see if it includes the endpoints or not.
And that's when you would change the bounds to like less than or equal to, or
That's correct.
yeah, or whatever.
That's correct. Mm-hmm. Very good. Any other questions about this?
Can you go over like how you would change the bounds? When you would change the bounds into
What
what?
do you mean when? I'm not sure what you mean by that.
Like after you check the endpoints.
Yeah.
Um,
Well, so if it converges, okay. So this is a good problem. So okay, let's do that. Let's think about that. What's going to happen in these, So let's put x equals -1/8 in. Now, we don't care about the left-hand side. Well, we're only interested in, does the right-hand side converge? That's what we're interested in. And even if it does converge, there's no guarantee that it's going to converge to the number on the left-hand side. It could, but it doesn't have to. So if I plug negative an eighth in, what do I get? Well, I'm going to get, let's just look at what the terms are going to be. So this is negative an eighth, or negative 8 over 3. And then this becomes times negative 1/8 to the power of 5. So you're going to get a negative times a negative, which becomes positive. So perhaps let's not kill ourselves with signs, because we're going to get an alternating thing. So you get 1/8 to the power of 5. And then this is going to be minus 32 over 3. And then since this is an even power, it's just 1/8 to the 6th. And then it's going to be plus 512 over 9, 1/8 to the 7th. So first off, we have an alternating series. And the question we want to ask ourselves, is it going to but the question we want to ask ourselves is, does it converge? So how do we know if it converges? It converges if the terms are going to 0 and it alternates. So what you would have to do is you would have to ask yourself, okay, what are these terms doing? And since we didn't write the general form down, we might want to go back and see, what is a general term? Like, what does the nth term look like? You know, we didn't write it down. We have this. So perhaps, you know, here's a good opportunity to see how we might look at the general term. So let's redo the problem. To get the nth term, or the kth term, whatever, let's call it the kth term, or the nth term, it doesn't matter. So let's redo the problem. We started with 1 over 1 minus x. Now, what does this thing look like? Well, this is 1 plus x squared plus, what's the kth term? The kth term is x to the power k. And then it keeps going forever, correct? The next thing I did is I plugged in 8x for x. So I'm left with 1 over 1 minus x equals 1 plus 8x plus 8x squared plus 8x cubed, etc. And then I get to 8x to the power k. This is a x, not a k. And then this, of course, keeps going. Well, I forgot my 8 over here. Hold on. So this is minus 8x. And then the next thing I did is I integrated. And when I integrated, I got negative 1/8 log of the absolute value of this. And then over here, what would the integral be? Well, this would be x plus, let's write it out in all its gory details, 8x over 2. Okay, so this would be 8 squared times x cubed over 3. And then what would the kth term? Well, this would be 8 to the power k times x to the k plus 1 over k plus 1. And then this continues. So this is now, we're trying to write it a different way so we can see what's happening to the kth term. Does anybody have a question, comment? Okay, so then what did I do? Then I wanted to kill that 8, so I multiplied everything by negative 8. And you're left with log of this. So we had negative 8x. And then what's going to happen to each one of these? Well, the powers are going to increase. This is negative 8 squared x squared over 2 minus 8 cubed x cubed over 3. And then this becomes minus 8 to the k plus 1 over times x to the power k plus 1 all over k plus 1. So when I do it this way, which is a little more difficult the first few times you do it, but when you do it this way, what you gain is you gain more information. The pattern is much more clear. So you might say to yourself, well, why didn't you do it this way originally? Well, I didn't because I think the way I did it the first time is the easier way to learn from. But once you get practice doing that, then you can go this route. And you can get more information. Okay, so once I have that, the next thing we did is we multiplied by what? 1/3 x to the 4th, I think. I think that was how we did it. So I'm running out of space here. I wish I could fit it all. Well, let's just squeeze it in. So what am I worried about? Let's just look at the kth term. The kth term, so I have this 8, but I'm multiplying it by something. I'm multiplying everything by 1/3, correct? I'm multiplying it by 1/3 x to the 4th. So when I just look at the kth term, all I want you to do is put your eyes right here. On this guy right here. We're going to multiply that by 1/3 x to the 4th. So what's going to happen to that? Well, you're going to get, and let's kind of write it in terms of variables and constants. You're going to get 8 to the k plus 1 over 3 times the quantity k plus 1. And then when I multiply it by x to the 4th, that means this power is going to be adding 4. So this becomes k plus 5. Whew. This is fun. Does anybody have questions or comments? Well, my head's ready to explode. This is good we did this, though. I didn't plan to do this, but I kind of like this. This gives you 2 different ways to study the same series. And you should do this on all of them, not just this one. It might even be more beneficial on 3 or 4A because on 4a, the series is a little not as complicated. Okay, so don't forget the kth term is, let me be very specific. This is the kth term of the series we're interested in. So the kth term is for this guy. It's for 1/3 x to the 4th log. So now what happens when x is -1/8? Well, when x is -1/8, you get something. Let's look at it. So let's rewrite this again on the following page. Let's be adults here. And I know that sounds mean. So what's the series? Well, it's the sum. K goes from something to something else. So let's see if we can put this together. So where do we start? Well, look at the pattern. It's 8 to the k plus 1. Over what? Well, it's over 3 times the quantity k plus 1. And then this is x to the k plus 5. So where does k start? Well, the first term we get what? The very first thing we get, if we look at the previous page, so the very first term should be -8 times x. But we're multiplying it by 1/3 x to the 4th. So the very first guy should be power 5. So this means k does start at 0. Now don't forget also that every one of these guys is negative. So remind ourselves, when k is 0, you get -8/3 x to the 5th. And then when k is 2, you get minus 8. When k is 2, you get 8 to the 3rd over 3 times 3. Excuse me, this is when k is 1. What am I doing? So when k is 1, you get minus 8 squared over 3 times 2, and then this is x to the 6th, and then that pattern continues. All right, so now we already know this converges between -1. It converges for x between these values, but now we have to check the endpoints. So now I want you to replace x with -1/8. And so what you get is you get -8 over k plus 1 divided by 3 times k plus 1. And then this becomes, you know, the 1 raised to anything is 1, so let's just write it as this, 1 over, this becomes -8 to the k plus 5. Now, again, this is a little sophisticated, so we're going to be very careful with how I do this. Notice in the numerator, the minus sign is not included in the k plus 1 power, but it is included in the denominator's k plus 5 power. So we have to be very, very careful with how we do this. So I'm going to rewrite it like this. And I don't know if it's going to be something you follow around too much or not. So this is, I have a -1 upstairs. Downstairs, I have a -1 to the power k plus 5. Then I'm down here, I have a 3 over k plus 1. And then upstairs here, I have an 8 raised to the power k plus 1. And down here, I have an 8 raised to the power k plus 5. So really what I did is all I've done is I've separated the things in the denominator. I'm writing them out explicitly. Now, why would I do this? Well, because now I can see exactly what this series does. It's clearly going to alternate. So how can I know it's alternating? Well, that -1 is a power 1 upstairs, and if I subtract, it doesn't matter how you want to do it. We know that the very first term is going to be negative. Actually, it's going to be, what is the first term? The first term is going to be positive. So we can just rewrite this as -1 to the power k. Well, let me write it. Maybe if I write it this way, it'll be a little more clear. So I'm just going to write this as -1 to the power k. And then this is over 3k plus 1, but that's a multiply. Now, how many 8s are left? How many 8s are left is upstairs you have k plus 1. Now, if you subtract the quantity k plus 5, the k's cancel out, and all you're left with is times 8 to the -4. That's all that remains if you do your algebra, your exponents. And so what you have here is you have a constant multiple of the alternating harmonic series. Ooh, ugly. So this is a constant multiple of the alternating harmonic series. And this converges by the alternating series test. Yikes, what a problem this is. Ooh. Okay, now what's going to happen if we plug +1/8 in? Well, the thing is it's not going to get the alternating thing, so it's going to diverge. If x equals +1/8, we obtain a divergent series. And I'll let you fill in the details. And so what we can conclude is we conclude the interval of convergence is you include -1/8. Let's not use that notation. We haven't used that. We've been using inequality. So we include -1/8, but we do not include +1/8. 4C's interval of convergence. This is quite a difficult one. Do not get discouraged if you have a hard time following. Do not get discouraged. Does anybody have a question about this? One of the questions you might have is, well, you say don't get discouraged, but shouldn't we know how to do it? Yeah, you should know how to do this problem, but my point is the difficulty level in doing this for 4A versus the difficulty level doing this for 4C is like night and day. I would encourage that you don't try to learn this on 4C, but try to do it on 4A first. And look, much of what you're going to see in 4A, B, and C when you study the endpoints is what you've already covered in problems 3, A, B, C, and D. You got to get a feel for what happens when you check the endpoints. And when you do a bunch of them, you'll start to see that there's, I don't want to say a pattern, but there's a general theme that keeps popping up. Any questions? Comments?
Wow, that was one problem.
Well, that's a brutal problem. It is. There's no doubt about it. But that doesn't mean you shouldn't know how to do it. Okay. Good. All right. So look, yeah, this is some deep stuff. So don't get discouraged. It takes a lot of energy to get to the bottom of all this stuff. Okay, Alyssa, you asked about number 2 from homework 11. Let's see what that is. This is homework 11. Oh, okay. So the question is do we have a power series? And if so, can we determine its center and coefficients? And it turns out this is a power series. We just have to learn how to write it correctly. So let's do that. So for number 2, you need to note that 5x minus 20 to the power k, it can be written like this. So let's factor out a 5. And then this is x minus 4, like this. And so this is 5 to the power k times x minus 4 to the power k. So that's just algebra. And so what this means is if you see this, which doesn't look like a power series, this doesn't look like a power series, well, because of that algebra above, we do know that it's the same series as this. Which has center equal to 4 and coefficients 5k. Does that make sense? Maybe? Perhaps. So that's really the purpose of problem 1 and 2 is to get you working with the words power series. What does it really mean? You know, one of the struggles for me when I was a student is I literally never, it was weird because like I said, Taylor series with the, there was all these words flying around and it took me a while to really appreciate and understand something. So problem 1, I'm saying, is every Taylor series a power series? And the answer is yes. Every Taylor series is a power series, but the opposite is not true. So this is sort of like the calculus version of every square is a rectangle, but not every rectangle is a square. Every single square is a rectangle, but not every rectangle is a square. So every single Taylor series is a power series. But there are power series that aren't Taylor series. And so it's interesting, it's important that you understand that a Taylor series is a special type of power series. And it's also important that you, look, I'm saying it's important. I'm not suggesting that you're going to understand this in the next 2 weeks. Let's be honest with ourselves here. Asking even students under the ideal circumstances, let alone a pandemic, to fully understand calculus in 4 months that's just insane. I'm not, don't get discouraged when you're confused by this. And you guys know how this goes. You're liable to take that test and the average is going to be a 50 or 60%. Does that mean you all flunked? No. There's really only so much we can learn in a given amount of time. And I understand and I appreciate this. But I want you to try to have, certain things you can learn and you can distinguish what is a power series, why is it a power series, stuff like that. Does that make sense? Does anybody have a question about this problem? I think we've done examples like 3. We did a few of those last week, I think. We've now showed you how to do 4. We've done a few examples with 5. We did 6, I believe, last class, and we've even elaborated more and more on 7. So we've given you a bunch of practice examples to check out for homework 11. That doesn't mean that it's easy for you to do homework 11. Watching and doing are 2 different things, right? You guys know this. I mean, I watch hoops. That don't mean I'm playing in the NBA. The way to learn this is to do it. And unfortunately, it looks like the standard way of learning math is to do lots of things and you get a lot of them wrong at first. I mean, think about certain things that require skills. I mean, my kid's learning how to ride a bike right now. So it's funny. If I just threw her ass out there on a real bike without training wheels, she would fall over and over and over again, right? And so what we try to do is we realize that it's difficult. So we give training wheels on a bike to help, so they understand the core muscles involved and the core movements involved in riding a bike. And then once your body gets that muscle memory, you can get rid of the training wheels. And even then, once you get rid of the training wheels, you're going to fall. That's just learning. Just like when you learned how to walk, you fell. You crawled first, and then you got brave and you fell. And eventually, your body understood the muscle memory, and it becomes second nature. Calculus is a very difficult thing to learn. And for most human beings, there's a learning curve that's super steep, and there's a lot of failure that happens before there's understanding. That just means you're normal. So please don't get discouraged, especially over the next few weeks. Life is much more important than all of this. But that doesn't mean, look, I'm not saying just give up. I'm saying when you stink at it and it's hard and you get discouraged, that's just normal. Try not to be. Just remind yourself, though Grady did it, you can do it. All right. Does anybody have any other questions? I know some of you have homework questions from previous homeworks. I meant to say this earlier. I know, for Katie, I know I owe you some stuff. One of the things I'm going to try to do over the next few days is post homework solutions. So, I'm not to call, I don't even know, Katie, are you on here? I don't even know if you are, but. Anyway.
Yeah.
You are, yeah. So not to call you out, but one of the things I would encourage you guys to do right now is don't stress about the homeworks 3, 4, and 5 right now. Try to make sure you can do the current stuff first. Because this stuff, I believe the homework you were asking about were the differential equations. Now, there's a good chance that'll show up on the final, but I can guarantee you this stuff's going to be on the final. You will 100% be asked to do intervals of convergence and power series stuff, for sure. So make sure the questions you have, so like, for example, when we meet tomorrow, if you're unsure about any problem on homework 11 and 10 and stuff, those are the ones to ask about. I will do my best to post solutions to the previous ones, and you could still ask about them, but my advice as an instructor to you, the student, is concentrate on like homeworks, 9, 10, and 11 right now. I hope that makes sense. Does anybody else have a question before I end this thing? All right, well then let's call it a day. I hope to meet. I plan to meet tomorrow, and I would also like to meet next week at least once, if not more. My goal is to give you the test so that you have a couple days where you can ask questions for me, and whether it's in class or via email and stuff. All right, so I'm going to start recording now.